The topic of this pencast is solving a word problem involving sale and discount or discount rate. My name is Darren Lacoste. Before watching this pencast, please watch the word problems pencast that explains the 4 problem-solving steps. Now that we understand the 4 problem-solving steps, let's talk about the type of word problem that involves sale and discount or discount rate. The quantities most often encountered in sale and discount rate problems, and their variables, are as follows. A capital S represents sale price measured in dollars. A capital O represents the original price, also measured in dollars. A capital D represents the amount of discount, measured in dollars. And a lowercase r represents the rate of discount, measured as a percent, often stated in the problem as a percent, but used in the equations as a decimal. I'd like to draw your attention to these last 2 variables, because if students make a mistake in this type of problem, it's usually because they confuse the two. D is the amount of discount. So if something originally cost $100, but you get it for $90, the amount of discount was $10. It's the $10 you didn't have to pay. As opposed to little r, which is the rate of discount. As I said, that's usually expressed as a percent. Alright, so let's apply this idea with the 4 problem-solving steps to an actual word problem. If a pair of shoes originally marked $90 is discounted 40%, what are the amount of discount and sale price? Alright, let's move through these 4 problem-solving steps. Step 1 always says, read and reread the problem, assign a variable, and write other quantities. Alright, well, let's remind ourselves. We've already read the problem. Let's reread it. We've got a pair of shoes, originally marked $90, so that's the original price, which is our variable O. It's discounted 40%. Notice the percent there. So that is little r, our rate of discount. And then it says, what are the amount of discount and sale price? Alright, well, with that information, we should be able to identify our quantities and what we are looking for. We have them all written here. So the sale price is capital S, the original price is capital O, the amount of discount is capital D, the rate of discount is lowercase r. We're given lowercase r and capital O. We're asked to find capital D and capital S. Okay, now we can move on to step 2. Step 2 says, refer to known formulas, sketch a diagram, write an equation. Well, one thing I'll point out right away is there is no diagram for this type of problem, so we just need to know what sorts of equations we're going to deal with. The sale price and discount rate problems always use the same 2 equations, and they are as follows. That the sale price equals the original price minus the amount of discount. Using our variables, that would be S equals O minus D. The other formula is that the amount of discount equals the rate of discount times the original price. Using variables, we write that as D equals R times O. And it's very important to recall that every time we wish to use the little r in this formula, we must express little r as a decimal. Okay, so let's go ahead and perform step 2 here. We referred to known formulas, we just wrote what they were. We said there's no diagram, so now we just have to write our equation. Usually that means plugging into the information that you're given. So let's start with S equals O minus D. So we can write that. S equals O minus D. Okay, so in this particular problem, we know some of the information, but we don't know all of the information. We have to find D and S for this particular problem. So let's go ahead and write both of our formulas here. So S equals O minus D, and D equals R times O. Okay, now that we have that, we were given little r and O. So it looks like we can calculate the discount right away. Let's start over there. So the discount D is going to equal little r. Little r is given to us in this problem as 40%. We have to write that as a decimal. So that's going to be 0.4. O is the original price, and that was given to us as $90 for this problem. Okay, and with that we should be able to calculate D. Looking at our other equation, now we have S equals O minus D, and we're trying to find both D and S. The only thing we know here is O. O is the original price, and that was $90. So S is equal to $90 minus D. So once we calculate D over here, then we can go ahead and come over to our other equation and put it inside, and we should be able to then solve for S. So first we have to get D, then we can get S. That moves us on to step 3, which is actually solving the equation. Okay, so let's start with D. We had D is equal to R times O, and we wrote that D was equal to 0.4, and that was being multiplied by $90. Okay, we do our decimal multiplication, and we find that gives us a discount of $36. If you were to try that problem on your own and you're not quite sure where 36 came from, please refer to the Pencast on decimal multiplication. That will explain that process to you. It will tell you where 36 came from. Okay, so now we have D. We all want to use the other equation, which was S is equal to O minus D. Well, now we know both of those, right? So S is equal to O. O is $90. Minus D, which is $36. And when we perform that subtraction, we find that gives us S is $54. Okay, so we've solved the equations. The last part of step 3 is to use the solution to the equation to answer the question being asked, include any necessary units. Alright, well the question that was asked of us was, what are the amount of discount and sale price? Well, D represents the amount of discount, so we can write the amount of discount and in parentheses I'll put D is $36. Okay, dollars is the units for this problem. Alright, and then we solved an equation for S. S was defined as the sale price. So the sale price, which is S, is $54. Again, dollars is the units for this particular part. That moves us on to step 4. You'll recall that when you get to step 4 and you're checking your answer, you're only using numbers. There are no variables anymore. And one way you can check your answer here is if you take the sale price and the amount of discount and add them together, it should give you the original price. Let's check and make sure we did it correctly. So, the sale price is $54. The discount, the amount of discount, is $36. And if we add those, that should give us the original price. Alright, 4 plus 6 is 10, write the 0, carry the 1, and 5, 3, and 1 makes 9, giving us a total of $90 as the original price. And if we look back, we find that indeed $90 was the original price for this problem. So, we've completed this, and we know that we have a correct answer because we've checked it. Okay, let's move on to another problem. Here's another problem. A store is having a 35% off sale on musical instruments. A customer was able to purchase a flute for $312. What was the original price of the flute? Now this is an interesting problem because we are given the final price, the sale price, and we're asked to find the original price. This is sort of an unusual problem because it's not one that we commonly find in the world. Usually when you go into a store, the original price is what's obvious to you. It's what's labeled. It's what's marked. So this is sort of a, okay, now we've gone home and we now have to remember what the original price was. All we have is our receipt telling us what we actually paid. And now we have to work backwards and figure out what was the original price. Alright, so let's use the 4 problem-solving steps. We're going to use them sort of informally in this problem. I hope that by now you are familiar with the 4 problem-solving steps. So, as a brief reminder of what they are, we will still go through them one by one. Step 1 says to read and reread the problem, assign a variable, and write other quantities. Well, we've got the same variables and quantities that we had in the previous problem. So we're still looking at the same variables, which were S and O and D and little r. And in this case, the question is asking us for the original price. So that's O. We want to figure out what is O. We are given some information, but not much. We're told that the store is having a 35% off sale. So that's going to be related to our R. So R is 35%, which we can express as a decimal, 0.35. We are also told that the price of the flute, the amount that the customer actually paid, was $312. Well, this was a discounted price. The amount the customer actually paid is not the original price, it's the sale price. So that is the value of S. So we know S in this particular problem is $312. And we have to figure out what O is. There's no information about D in this problem whatsoever, and we'll see how we use D in just a moment. So step 1 was to read, reread, assign a variable, and write other quantities. I think we've done that sufficiently. So now we can move on to step 2. Refer to known formulas, sketch a diagram, write an equation. Again, there is no diagram. The known formulas are the same known formulas that we used back in the previous problem. So I'll just remind you what those were. They were the sale price equals the original price minus the amount of discount, or in variable form, S equals O minus D, and the amount of discount equals the rate of discount times the original price, or in variables, D equals R times O. So let's go back to our problem here and write those down, because those are going to be very useful to us. So we have that S is equal to O minus D, and we have that D is equal to R times O. Now, what makes this problem so interesting is individually, each equation cannot be solved. Now, why is that? Let's look at this first one. S equals O minus D. We know S, but we don't know O and we don't know D. And you cannot solve an equation that has 2 variables in it if you only have one equation. We have the other equation, D equals R times O. We know R, but we don't know O and we don't know D. So again, we can't solve that equation by itself either. So what we have to do in this particular problem is put these 2 together. Only when we do that can we actually get one equation with one unknown variable in it. And the way we're going to do that is we're going to recognize that this D and this D are the same. Since D is equal to R times O, then we can actually make a substitution in the first equation. And instead of writing D, we can write R times O, because we know D equals R times O. So this gives us that S is equal to O minus R times O. Now we have one equation. Our unknown is O, and the other things in our equation are the S and the R, and we know both of those. So now we can actually solve this equation. So let's go ahead and plug in what we know. S is 312. That equals O minus R, which is 0.35 times O. Now we'd like to be able to combine our like terms here. Our like terms are the terms that have the O in them. Remember that O is our variable. To do that, we have to figure out what the coefficients are. That makes this a little bit tricky. And with this, we now move into step 3. Step 3 is to solve the equation. So let's look at the coefficient of this O right here. It's an O that stands alone. There isn't a number in front of it, but there is a hidden number there, and that number is 1. So we can rewrite this as $312 is equal to 1. I'm going to write it as 1.00 because I'm going to anticipate we've got some decimal subtraction ahead of us. So we've got 1.00 minus 0.35. Now remember how we combine like terms. We just work with the coefficients. So we've got 1 we want to subtract 0.35. So we're going to subtract the decimals. So let's move over here to our scrap work. We've got 1.00 minus 0.35. We cannot take 5 from 0, we have to borrow, but we can't borrow from 0. So we've got a double step here. We're going to borrow from this 1 and add 10 to the tenths place. Still can't take 5 from 0, so we're going to borrow from the tenths place, turning the 10 into a 9, and add 10 to the hundredths place, making that into a 10. Now we can do our subtraction. 10 minus 5 is 5, 9 minus 3 is 6, and that leaves us 0.65. So we have $312 equals 0.650. One of the nice things about decimals is you can think about it in terms of money. So we had 1.000 minus 0.350. Think of that as if it was currency. If you have $1 and you take away 35 cents, that's going to leave you 65 cents, which you can write as 0.65. All right, one more step here in step 3. We need to solve for O. Since 0.65 is multiplying by O, we want to use division to undo that. So we'll rewrite what we have, the two sides of our equation, and then divide both sides by the coefficient, which in this case is 0.65. By the multiplication property, we know that those things are now equal because we took an equation and divided both sides by the same non-zero number. Using the basic principle of fractions, we can in essence cancel these two instances of 0.65, and we're going to get O on the right. On the left, we have to do some long division. We have 312 divided by 0.65. So let's again come over to our scrap work. We have 312 being divided by 0.65. Now you probably remember the rule that if your divisor has a decimal, then you're not allowed to do your long division until you turn it into a whole number. So we want to move this decimal point 2 spots to the right. But in order to do that, we have to actually move the decimal point in our dividend 2 spaces to the right as well, and then add a couple of zeros. So now we're looking to divide 31200 by 65, and that's going to give us our answer in terms of dollars when we're done. Alright, so 65 does not go into 3, and also does not go into 31, but it does go into 312 4 times. 4 times 5 is 20, so we write the 0 and carry the 2. 4 times 6 is 24, plus 2 is 26. With that we can subtract, leaving us 52. We bring down the 0. 4 was how many times we could take 65 out of 312. So how many times can we take 65 out of 520? Well, it should be more than 4, since 520 is more than 312. This could be a little bit tricky. 65 is halfway between 60 and 70. So let's try a couple of things. If we had, for example, 70 going into 52, that's the same thing as 7 going into 52, which happens 7 times with a little bit left over. If we think of 65 as 60 going into 520, that's the same thing as 6 going into 52, which happens 8 times. So it's probably 7 or 8. We don't know which one, so let's just pick one and hope we get the right answer. Let's try 8. So we'll write an 8 there. 8 times 5 is 40, so we write the 0, carry the 4. 8 times 6 is 48, plus 4 is 52. Look at that, we got lucky. It's the exact amount that we needed. That's absolutely fantastic. We still have one more digit. We have to bring that down. And when we do, we realize that 65 goes into 0 times. And that gives us our answer. Our quotient is $480. So 312 divided by 0.65 is 480, and our units are dollars. So that gives us O equals 480. Now, step 3 says not only do you have to solve the equation, but you have to interpret it so that it answers the question the word problem asked. Luckily, we were very careful in how we defined what O meant. O is the original price. And the question says, what was the original price of the flute? Therefore, we know the original price of the flute was $480. Let's write that. Alright, fantastic. So with that, now we can move on to step 4. Step 4 is where we check our work. Well, one of the ways that you can check your work in this type of problem is to work backwards. If the original price was $480, then we should be able to calculate the discount amount, knowing that it was 35% off, and then when we subtract the amount from the original price, we should get the sale price. If we go through that whole process and we end up with $312, then we know we have a correct answer. Let's give it a try. Okay, so using our formulas from before, and I'll remind you what those are, we have S equals O minus D, and we have D equals R times O. Let's try this. Okay, so S is equal to O minus D, and D is equal to R times O. Let's calculate the discount first. So the amount of discount is equal to the discount rate, which will be 0.35, times the original price, which is $480. Okay, so we need to once again do some scrap work. I'll come down to the bottom of my page here. So we've got 480, and we're going to multiply that by 0.35. Okay, I'll put a 0 and a dashed line there just to remind me that I'm not going to actually use that 0 as part of this multiplication. Alright, so here's a little trick. 5 times any number can be attained by taking that number and multiplying it by 10, then dividing by 2. Or dividing by 2, then multiplying by 10, either way. And the reason why is because 10 divided by 2 is 5. So 480, if you cut that in half, you get 240, and then add a 0 for multiplying by 10. That's 2400. Okay, placeholder 0. We'll do the rest of this multiplication the long way. 3 times 0 is 0. 3 times 8 is 24, so we write the 4 and carry the 2. 3 times 4 is 12, plus 2 is 14. Let's add our partial products. We have 0, 0, 8, 6, 1. And then we have to keep track of how many decimal places were in each factor. Here we had 0 decimal places. Here we had 2 decimal places. So our final answer is going to have 0 plus 2, or 2 decimal places. And we can put that decimal right here. Of course, we're dealing with money, so the actual discount amount is $168. Okay, now we can move on to the other equation, which says that the sale price is equal to the original price minus the discount. Let's plug in. The original price, we found by solving the problem that the original price was $480. Remember here, we're checking our answer. And we want to subtract off the $168, which we just calculated, as the discount. Again, returning to the bottom of the page to do our scrap work. 480 minus 168, we want to subtract. We can't take 8 from 0, so we borrow. In the tens place, we turn that 8 into a 7, which allows us to add 10 in the ones place. 0 plus 10 is 10. Now we can do our subtraction. 10 minus 8 is 2. 7 minus 6 is 1. 4 minus 1 is 3. So that gives us S is equal to $312. That matches the information we were given originally. Therefore, we have checked and we have a correct answer. Step 4 is also a reality check. So let's apply the reality check as well. The original problem was that the store was having a 35% off sale on musical instruments. A customer once was able to purchase the flute for $312. What was the original price? Well, we would expect that the original price would be more than $312. If the customer was able to buy the flute on sale for $312, the original price certainly must have been more. And we expect it to be a little bit more, but not ridiculously more expensive. 35% off is almost a third off. So when we look at our answer, $480, we find that that is quite reasonable. It's relatively close to $312, but it's more, which is exactly what we expected it to be. Okay, we made it through all 4 of the problem-solving steps, and we have an accurate solution to our problem. We've completed 2 examples on this particular topic. I hope you found this pencast useful, and I hope you will listen to more of them in the future. Good luck!